about probability, specifically with regard to contingency tables, because that is something that comes up regularly in exams. So the first thing that I wanted to have a look at was a question that I found. Let me just make it a little bit bigger. Okay, and you can see here that this is out of 5 marks. And what they've done is that they've asked us to look at information about people on a flight, and that they could choose between whether they wanted something that was vegetarian or something that was chicken, and then whether it was men or whether it was women that chose that particular snack on the plane. And then they ask us, was the choice of snack on this flight independent of gender? Motivate your answer with necessary calculations. So before we get started on answering the question, let's just first talk about what does, when in probability, when we talk about events being independent, what does that mean? So from what you recall from, what are independent events? What does that actually mean for us? Does anybody know? So in probability on its own, not a bad suggestion. Not quite, not exactly right, but anybody else got an idea what the word independent means in this situation? Okay, so if you're not sure, let me just explain this to you, because I mean, there's no point us talking about independent. There we go, Maya. The outcome of the first event influences the second one. So those are dependent events, okay, where that would happen. So an example for you, just to illustrate the difference between dependent events and independent events. Let's pretend that I wanted to share, or let's say we were going to take marbles out of a bag. Okay, so let's pretend that we've got red ones and we've got blue ones, and let's pretend that we've got 7 marbles, and we're going to say that 3 of them are red and 4 of them are blue. So that means that if I put my hand into the bag and I randomly choose a marble, I've got a 3 in 7 chance of getting a red one, and I've got a 3 in 4 chance of getting a blue one. Now let's pretend that I put my hand into the bag, I look at the color of the marble, and then I decide after that I'm going to put the marble back into the bag. So the second time when I want to take out another red marble, I still have a 3 in 7 chance of getting a red marble, because there's still 3 red marbles in the bag and there are still 7 red marbles. Does that make sense to everybody? So in other words, what's happening as far as my second choice of R is concerned, it's completely independent of what happened the first time round. Okay, so the fact that I took the marble, looked at it, put it back into the bag does not affect the outcome the second time round. If I'm talking about events that are dependent, then this would be a situation where, for example, again, let's say I've got 7 marbles, 3 red, 4 blue. So the first time that I put my hand in the bag and I want to take out a red marble, I've got a 3 in 7 chance of being able to do that. But let's say this time I don't put the marble back in the bag. I keep it. So I look at the color, and instead of putting it back, I put it on the side. What is the chance of me choosing another red marble in this case? You can put it into the chat or unmute. It's up to you. What would be the probability? Of me choosing another red marble. Okay, so Sipasihle, Nick, your answers are correct. Okay, so Liam, iPhone. Okay, there are not going to be 7 marbles left in the bag because remember, I've taken a marble out. All right, and I've looked at it and I've put it on the side. I haven't put it back into the bag. So that means that there are now 6 marbles in the bag and only 2 of which are going to be red. So my outcome for choosing the second red, all right, depends on what happened with the first. So these are dependent events. Okay, so here you can see with independent events, we would have ended up with RR being 3/7 times 3/7, which would have given us 9/49. And here it would be different because we'd end up with 3/7 times 2/6. So that would give us 6/42. All right, so our probability of choosing a second red marble is affected by the fact that we didn't put the first red marble back into the bag. Does that make sense to everybody about the difference between independent and dependent events? Everybody happy? Thumbs up, smiley faces, we're all good. Okay. All right, awesome. Okay, so Kensani, why do you need me to explain everything again? Have you just joined us or did you not understand what I was saying? Oh, you just joined in. Okay, in that case, what I'm going to do is I'm going to get Neliswa just to type your message, Neliswa, if you don't mind, and just tell Kensani what it is that we've been discussing. I'm not going to move away from this because I'm going to continue to talk about it a little bit before we actually get started on the question. Is that okay, Neliswa?
Yeah.
Okay, all right. So Neliswa will explain, and you too, and of course, Neliswa will just explain to you what it is that we've been discussing quickly. Okay, so the other thing that we need to know for events that are independent, there is a rule. Okay, so we need to know what that rule is. Does anybody know what the rule is off the top of their heads? The rule for independent events. So if you have events A and B, and they are independent events, then there is a rule, it's called the product rule, that we can use. Let's have a look what you guys are saying in the chat. Multiply, you're quite right, Nick. Okay, so in other words, the probability of A and B, and the other way that we can write that is the probability of A intersection B is equal to the probability of A times the probability of B. Okay, so in this case here, you can see that 3/7 times 3/7 would be 9/49. So that would be the probability of us getting red and red, all right, if we did not take a marble out of the bag when we left it in the bag. Now, when we talk about the word and in probability, what does the word and mean? It's got a very specific meaning. What does the word and mean? Yes, together. Both of them. Okay, so it means both at the same time. Okay, so in other words, you are in matric and you attend Watobe. Does that make sense to you? You're in matric and you are attending Watobe. So in other words, you are doing both at the same time. Okay, so the word and has a very specific meaning, and that's quite right. When we use the word and, we're going to be multiplying our probabilities together. Okay, so this is called the product rule for independent events, and we can use this rule to determine whether events are independent or not by looking to see whether the left-hand side equals the right-hand side. So like with anything in maths, we're not allowed to start off assuming something is true in order to prove that it's true. We have to find evidence, I say in inverted commas, to support whatever it is that we are trying to prove or show or whatever the case is. So when they ask you to prove that events are independent, all right, they do not want you to write the formula as I've given it to you here. You need to work with the left and the right-hand side separately from one another. And if they are equal, then you can conclude that left-hand side equals right-hand side and that the events are independent. Similarly, if the left-hand side did not equal the right-hand side, then you could conclude that the events are not independent. Okay, so just depending on what it is that they ask you to show. All right, so let's have a look at this first one. I'll move the other question out from underneath it. Just give me a second here. Let's pull this down. And then let's get the other one. That one. Sorry, I'll just pull this out as well. We can have a look at those now. All right, so the first one that we had a look at was on the flight. Okay, so passengers can choose. Oh, by the way, what is this thing called that I've given you in this question? What is this? I'll just draw a circle around it for now. What is this thing referred to as? What do we call these in probability? Not a bad idea, Maya. Not exactly. It's not a sample space. Anybody else know what they're referred to as? At least I'm going to turn my video off now just to sort of try and preserve some of my bandwidth.
Is that an LED?
Is that okay? So I'm just going to say stop video. There we go. Okay. All right. Let's see. There we go, Naledi. There we go. That's it. Okay. It's called a contingency table. There's another word for it as well. Does anybody know what the other word is for it? Oyama, what did you want to say? Yep, contingency table is correct. What else do we refer to it as? The next word is not really a very sophisticated one. It's a two-way table. Okay, and the reason why we call it a two-way table is because there's two different things that we can look at. So if we're looking at the columns, we're looking at gender. If we're looking at the rows, then we're looking at the type of snack that somebody would have chosen. Does that make sense to you? So we're looking at it from two perspectives. The one is gender, and the other one is the type of snack that the person has chosen. Okay, so they've given us this table, and they've told us that as far as vegetarian are concerned, there are 32 people who chose the vegetarian snack as opposed to 118 people who chose a chicken one, right? Looking at it in terms of the columns, okay, there are 67 males and there are 83 females. So it has to total both in terms of going across the rows and coming down the columns as well. Okay, what they can also do, and I've got an example of this later on to show you, is that they can leave some of these values out, and then you have to go and work backwards by subtraction to work out what was supposed to be in this particular cell. So in this particular cell over here, the one that I've just put the blue dot next to, how would I describe that? What does that cell mean? If I wanted to refer to that cell, what would I call it in this situation? Does anybody know? Okay, so this block, let's just see what you guys have said. You don't understand the question. Okay, so if I say to you, I'm referring to the cell, okay, so the one that has 12 in it. What does that 12 mean? What is that 12 telling us? What is the meaning of that number 12? Okay, absolutely. So in other words, there are 12 people that are male and vegetarian. Okay, so the number of people that are male and vegetarian is 12. Exactly. Okay, if I talk about this one over here, 20, the number of females and vegetarian, so they're both at the same time, there are 20 of them. So these cells here are they are both at the same time. So male and vegetarian, or male and chicken, or female and vegetarian, or female and chicken. Okay. And the reason that we need to know this is because if we're going to prove that choice of snack on the flight is either dependent or independent of gender, we've got to base our calculation on one of these four things. So you've got a choice. Either you can look at male and vegetarian, or you can look at female and vegetarian, or you can look at male and chicken, and you can look at female and chicken. The choice is completely up to you. There are four different ways of being able to do this, right? And when you answer a question, you have to make a decision in the very beginning. What am I going to look at? Because if you're going to look at male and vegetarian, then you've got to look at the probability of male times the probability of vegetarian to give you the probability of someone being a male and vegetarian. Or you could look at the probability of someone being female and choosing chicken. And then you would have to consider the probability of someone being female times the probability of someone choosing chicken. Okay, so there's four ways in which we can answer this particular question, depending on which cell we use. Does that make sense? Does that make sense to everybody? Cool. All right, so nice. Oyama, you've got a hand up. What's up?
It doesn't make sense to me. Like,
Yes. All right. All right. So what I'm going to have to do, Oyama, is I'm going to have to show you through an example that I'm going to use what it is that I'm trying to say. Okay, because what I'm trying to get at here, that's a little bit of writing involved here. There are four ways in which I can answer this question. Okay. So the first way is to consider the probability of someone being male and vegetarian. Is that equal to the probability of them being male times the probability of them being vegetarian? That's the first way. The second way I can look at it is the probability of them being male and choosing chicken. And then again, I'm going to have to look at the probability of them being male times the probability of them choosing chicken. The third way that I can look at it is the probability of someone being female and vegetarian. So then I'll have to consider the probability of being female times the probability of them being vegetarian. And then the fourth way that I can look at this is the probability of someone being female and choosing chicken. And that has to be the probability of someone being female times the probability of them choosing chicken. So you can pick, Oyama, any one of those four to prove it and work with the left-hand side and the right-hand side independently of one another. Does that make more sense to you? Oyama, does that make more sense?
Yes, it makes sense.
Yeah, the birds are saying yes too. Okay, so Oyama, pick one. Pick 1, 2, 3, or 4.
4.
Good. I'm so glad you chose female. Okay. All right. So number 4, let's look at it from that perspective. Okay. So we've got to do it left-hand side and right-hand side. Okay. So the probability of someone being female and choosing chicken. Okay. So Ayama, go and look at the table and which block is for female and for chicken. How much is in that block?
83, 63.
It's 63, exactly. Okay, so 63 out of what?
83.
No, there's 83 women. So we're talking about in total, out of the total number, because remember we're considering both male and female, right? So it's going to be 63 out of 150, exactly. All right, so on the left-hand side, we have 63 out of 150, which if you want to then put that into a calculator and write it as a decimal, you can do that. All right, so I get 21 out of 50, that's 0.42. You guys getting the same answer? Now we have to consider, all right, in a separate calculation, what is the probability of someone being female multiplied by the probability of someone choosing chicken? So what is the probability of somebody being female on the flight? What is the probability? What is the probability of someone being female on the flight?
$83 over 150.
It is. Okay, so Edisha, you've got the right idea. Okay, so it's going to be 83 out of 150. Okay, Matrix, so the total of the female column, there are 83 women on the plane. Okay, 83 out of 150. All right, so this probability of being female, there is an 83 in 150 chance of someone being female. What is the probability of somebody choosing chicken? What's the probability of somebody choosing chicken? Not 63? That's female and chicken, but somebody choosing chicken? Ah, there we go, Nick, 118 out of 150. So you're looking at the total column. Okay, so the total number of people that chose chicken. All right, so that would be agreed. It's 118 out of 150. So here we would have to multiply this by 118 out of 150. So let's work out what our answer is. Okay, so we're going to take 83 over 150, and we're going to multiply that with 118 out of 150. What do you guys get? Oof, some nasty. Zero comma 44, absolutely. So I've rounded this number off to 4 decimal places, which is something that we often do with probability. You know, we can look at it up to 4 decimal places to give us an idea of how similar the two are. So they're not that far off, but are they identical? Would we say that 0.42 is equal to 0.44? No, we wouldn't. Okay, and this is exactly why we cannot start out making, sorry, the hardy-dos are really loud. You cannot start out making assumptions because the left-hand side does not necessarily equal the right-hand side. So that's why we can't write that it does in the very beginning, because here we've proved that the left and the right-hand side do not equal one another. So we would now need to make a conclusion based on this. So what we would say, let me just move this down a little bit. So what we would say now is we would say that the probability of someone being female and choosing chicken does not equal the probability of someone being female and someone choosing chicken. So the left-hand side does not equal the right-hand side. So therefore the events are Independent or not independent? What do you think, Matrix? Dependent or not independent? Okay, so some of you are saying dependent, which is right, not independent. Okay, they're not independent because the left does not equal the right-hand side. So the events are not independent. So in actual fact, what we're learning here is that gender does have a role to play on the type of snack that someone is choosing, in other words. Yeah, they're dependent, yes, because the left doesn't equal the right, Maya. If the left equals the right, then they are independent. Does that make sense? If the left equaled the right, then the events would be independent. It's like what I've written here in red. If the left-hand side equals the right-hand side, then the events are independent. If they don't, then they're not. Go for it, Maya.
Hello, ma'am.
Hello, how are you?
I'm fine.
That's good. What did you want to ask?
Isn't independent events when the outcome of the first event doesn't influence the second one?
Correct. Correct, yes, it is.
That's what we said, right? So, ma'am, here are you saying that being a female actually influences what type of snack they choose?
Correct.
Okay,
Correct.
thank you.
So according to this data, yes, it does. Okay, so gender has an influence on what sort of snack that they chose. Quite right. That's exactly it.
Okay, thank you, ma'am.
Okay, all right, no problem. Quite right. Okay, does that make sense to everybody? How are you guys feeling about this? Making more sense to you? Any questions? Sure, all good. It's doable. Makes sense. Okay. All right, cool beans. Well, then in that case, shall Naledi, listen to me. Shall Neliswa and I keep quiet for a little bit and we can let you guys try 9.2. And when you're done, you can put your answers in the chat. Okay, so here they're not asking you, first of all, to calculate or to prove whether things are dependent or independent. That comes in 9.2.2. They're just asking you to calculate some probabilities. All right, so this is also a two-way table, except now we've got 3 rows instead of just 2. So we're looking at monthly income, all right, in rands. So either a home brings in less than 3,200 Rand a month, or there are homes that bring in between 3,200 and 25,000, and then homes that bring in more than 25,600 Rand a month. Okay, I see some hands up. What's up, guys? Are there questions?
Sorry, ma'am.
Yes.
With the question that we just did,
Yes.
you said we have 4 ways to answer the question, right?
Yeah.
So with the two-way table, depending on how many columns and thingamabobbies they give us, do we always have multiple ways of answering it?
Absolutely. Absolutely. So is your name Monde?
Yes, ma'am.
Okay. Did I pronounce that correctly?
Yes, ma'am. Good, thank you.
Okay. All right. So Monde, let's say you decided that you didn't want to look at female and chicken and you wanted to look at male and vegetarian. You would have done the same calculation, but for male and vegetarian. And you would have also arrived at a situation where your left-hand side did not equal your right-hand side. And similarly, you would have concluded that the results were not independent of one another. So yes, every single time that you do this, unless of course they ask you specifically, you know, is the, you know, are the events of being female and vegetarian independent, then you would have to use female and vegetarian. But if they didn't specify, so like in this question where they've just said to you, was the choice of snack independent of gender, it means you can choose the gender and you can choose the snack.
Okay, ma'am. Thank you very much.
Okay, no problem. So yes, Amal, you're basically choosing one concept, all right? So either are you looking at male and vegetarian, or male and chicken, or female and vegetarian and female and chicken. You've got to make a choice, okay, about which one you want to look at. All right, and then you just work with one of them. You don't have to prove things twice in maths. If you can just prove it once, then that's it, it's done. So I don't know, maybe before we go on, do you want me to just show you with one of the other? So like, let's say if we used male and vegetarian, how we would actually arrive at the same answer. Shall I do that quickly? Okay. All right, Amanda, let's do it. Okay. So let's say, okay, so we've chosen female and chicken. Let's choose male and vegetarian. Okay. Just for, okay. Green light. Cool. Okay. So male and vegetarian. So the probability of being male and choosing a vegetarian snack. So probability of being male and vegetarian is how much? Male and vegetarian, what would that give us? What probability? Okay, not out of 32 or 33. Remember, there are 150 people on the plane. Okay, so it's got to be out of the total number of people. Okay, otherwise we're not considering it in two different ways, right? Then we're just looking at just the vegetarians on the plane. So if you say 12 out of 32, all right, then we're just looking at vegetarians. We're not looking at everybody on the plane. Okay, and remember what we're trying to work out is whether the choice of snack is independent of gender. So we can't just look at the vegetarians and we can't just look at the chicken. Okay, we've got to look at everybody. So in fact, what we should have here is 12 out of 150. Okay, does that make sense to everyone? No stress, Nick. It doesn't matter if you get it wrong. It's just cool that you guys are trying. Okay, so I don't know about you guys, but I get 0.08. Do you agree? Okay. All right. Now, since we've chosen male and vegetarian, now we have to consider the probability of someone being male multiplied the probability of someone being vegetarian. So what is the probability of someone being a male on the plane? There we go, Adisha. Okay, so the probability of someone being male on the plane, quite right, is 67 out of 150. The probability of someone being vegetarian is, there we go. Okay, 32 out of 150. And again, we need to work out what the answer to this is. So we're going to say 67 out of 150 multiplied by 32 out of 150. And that's going to give us, again, can you see the left and the right are not equal to one another, matrix? So 0.095. I'm just going to round it off to 3 over here. Okay, so you would arrive at the same conclusion because the probability of the left-hand side does not equal the product of the probabilities on the right-hand side. So in other words, again, we would conclude that the probability of being male and vegetarian is not the same as the probability of being male times the probability of being vegetarian. They are not equal. Okay, and therefore the events are not independent. Okay, so that would be not independent. Okay, because the left does not equal the right. So they are independent if the left equals the right. They are not independent if the left does not equal the right. Not independent is quite right. Okay, not independent, that's it. Cool. How do you guys feel? Does it make a bit more sense? Yeah, you have to say that they're not independent. You have to say that, okay, because the question asked us here, right? It said to us, was the choice of snack on this plane, let me just move this, independent of gender? Okay, so you have to answer the question, right? And they want us to motivate our answer with the necessary calculation. So in maths, when they ask us to answer a question, they want us to answer that. All right, so we would have to say either the events are independent or not independent. There would be a mark for that in this particular case. Okay. Oh, good. I'm glad you guys feel better about it. Okay. Neatly. Fantastic. I'm so pleased. That's great. That's really awesome. All right. Should we go and have a look at the next question? You guys ready? Okay. All right. So this one is just, it's the same. Why? Oh no, Nick. There's always more work. So yeah, in question 9.2, we're also going to be looking at something, but I think they've specifically said to us in this case. So they've said to us, prove that earning an income of less than 3,200 per month is not independent of the area in which the person resides. So they haven't left the question open for us to choose. We have to go and have a look specifically at the cell where somebody is earning less than 3,200 Rand a month. Okay, so they've given us a specific place that we need to focus on. Okay, so either we would be looking in, let me just highlight it for you, in the cell over here. Okay, so that's the one that they want us to focus on. So we would have to consider people living in a specific area and them earning less than 3,200 Rand a month. But before we get there, we'll get to that question. Let's just talk about the probabilities that they want us to first calculate. Okay, so now they've asked us, what is the probability that a person chosen randomly from the entire sample? Okay, now how many people are there in the entire sample? How many people make up the entire sample? That's it. Okay, so 2,646 people in total. Okay, so we just happen to have 3 rows this time instead of 2 rows, and that's because they've just divided the brackets of what people earn into 3 categories instead of just 2 categories. Okay, so the total number in the sample is 2,646. That's the number that we're going to be dividing by. All right, so what is the probability that the person is going to be from area 1? Okay, so somebody's already put up an answer for that. Let's just have a look at what you said. There we go. Okay. Okay, 100%. So it is. It's 500 out of. So the probability of someone being from area 1 is 500 out of 2646. Okay, good job. And then of course we could simplify that a little bit. Let's just do that quickly.
Wouldn't it be the total of people from area 1?
Oh, sorry, it would be the total from people. Of course it would. Sorry, you're quite right. Thank you. It would be this number over here, 1832. Yeah, so the total number of people from area number 1. Okay, so I'm going to round that to 4 decimal places. So 0,6924. Okay, does that make sense to everybody? Because there are 1,832 people that live in area 1. Yes, Emihle, I'm sure. Yep, that's 2 marks. Okay. Yeah, so the number of people that come from area 1 and earn less than 3,200, that's 500. But the total number of people from area 1 is 1832 out of 2646. Okay, so that is very definitely correct. Okay, now we're being more specific. From area 2 and earn less than 3,200 Rand a month. What's the probability there? There we go. Okay, so if you come from area 2 and you earn less than 3,200 Rand a month, there are 460 people out of the 2,646. Quite right. Okay, so here, let's just get this one down. Okay, so there was a question. Someone had their hand up. What did you guys want to ask?
Afternoon, ma'am.
Good afternoon. How are you?
I'm finding you, ma'am.
I'm very well, thank you.
Concerning the number B,
Yeah.
right, ma'am?
Mm-hmm.
They said what is the probability that a person chosen at random from area 2 will and earn less than 3.2 per month, right?
Yes.
Which is 460. Isn't it going to be 460 over 960 because it's the total of people that earn less than 3,200?
No, so what they're trying to do here is that they're not just looking at the people that earn less than 3,200. So and Shema, this is one of the things that you guys probably nobody's explained this to you before, but we don't do conditional probability. So in other words, we don't do the probability of something given another set of conditions. That does exist, but it's something that is done in AP maths or it's done at university level. So here they're not talking about a conditional probability. They're not saying what is the probability of somebody coming from area 2 given that people are all earning already less than 3,200 Rand a month. They mean the number of people from area 2 and earning less than 3,200 Rand a month in comparison to everybody. Okay, so it's always going to be, when you're working with contingency tables, it's always, your denominator is always going to be this value over here. Okay, because it's not conditional. Okay, it's based on everybody. Does that make sense?
Yes, ma'am.
Okay. All right, and then the third question. So a person from area 2 who earns more than or equal to 3,200 Rand a month. So now what are we going to do here for part C? Let's choose a different color. Let's see what you guys are saying. So now I disagree with all of you, because people that come from area 2 that earn more than or equal to 3,200 can also be those people who earn more than 25,600, right? So it's 2 cells added together, because the people that come from area 2 that earn more than or equal to 3,200 Rand, it's these people over here, yes, but it's also these people over here. Does that make sense to you? Okay, so this was a little bit of a sneaky question. Yeah. Okay, so if you earn more than 25,600 Rand a month, you still earn more than or equal to 3,200, don't you? Okay, so you're going to have to add those two together. So, Katlwano, if you earn between 3,200 and 25,600, or if you earn more than 25,600, it's still more than or equal to 3,200, isn't it? So what you would have to consider here for this one is, so the probability of this is going to be 340 plus 14 over 2646. Okay, so as people are saying, it would be 354 out of 2646. Okay. All right, yeah, these questions are deceptively, well, you think that they're really, really straightforward, but you've really got to think in order to be able to answer them. Okay, so that's what they were going for in this particular question. Okay, how are we all feeling now? It's making sense. Mentally drained, yeah. Okay, we're nearly there. Okay, it's the 22nd of September. We've got October to get through and the beginning bit of November. So you've got like, okay, so until your exams are over, you've got 2 months. All right, you just got to hang in there. Oh, wow, Nick, that's hectic. Are you still busy writing trials, Nick? Wow, that's crazy. Anybody else still busy writing trials? Okay, you've got 2 papers left. Okay, Cassandra. Sure, and you, Kamogelo. And you, Ibrahim. Okay, oh, all right. Oh, you're writing maths tomorrow. Okay, Eminem. All the very best. Okay, we're thinking about you. You guys are very brave. Okay, so paper 1 tomorrow. Okay, so it's exactly this sort of stuff. Okay, done Friday. Okay, so at least there's a light at the end of the tunnel. You're nearly there. Okay, you can do it. If Nelisa and I could do it, you can do it as well. Oh, done today. And you still came to Watobe. That's pretty awesome. Well done. Good job. Of course you can do it. Of course you can. At least when I did it, you can do it. There's no doubt. Okay, so we've just got a little bit of time left. There's also a quiz for you guys to try this evening. So we'll head off a little bit earlier so that you can do that. Let's just have a look at question 9.2.2. So they want us to prove, now they're being very specific now, where they've asked us to prove that earning an income of less than 3,200 Rand a month is not independent of the area in which the person presides. Okay, so because they have directed us to a specific row, right? That means that we have to work within that particular row, right? So in other words here, they're asking us, we have to prove again. So it's similar to the first question that we did, right? But they want us to look very specifically at this row over here. Okay, so in other words, the row where people are earning less than 3,200 Rand a month. And they want us to show that it's not independent. Okay, so in other words, the amount of money that a person earns in a month affects whether they live in area 1 or lives in area 2. Right, that's what they're asking us to show. Okay, so what is one of the possibilities that we can look at? Anybody got an idea? Okay, but before you do that, Nick, you've got to make a decision. All right, so if you're going to consider the probability of somebody living in area 1 and earning less than 3,200 Rand a month, then that's fine. Okay, we can do it that way, right? In which case you've said it's 500 out of 2646, which is perfect. So now on the right-hand side of your equation, Nick, what are you going to consider? How are we going to, what's the right-hand side of our equation? So the left-hand side of our equation is area 1 and less than 3,200 Rand. What's on the right? No, again, in words, not in numbers, in words. So it has to be the probability that you live in area 1 multiplied by the probability that you earn less than 3,200 Rand a month. There we go. Okay, Amal, you've got it. Okay, so we've got to compare 500 over 2646 with the probability of living in area 1 multiplied by the probability of earning less than 3,200. So now we're going to go back. We're going to look at the table and we're going to say to ourselves, what is the probability that somebody lives in area 1? We've actually already got that answer. We know that it's exactly. So that's the answer from A. We've got 1832 out of 2646. Okay, so now what's the probability of somebody earning less than 3,200 Rand a month? That's it. Okay, hundreds, yes. Yeah, we're on 9.22, yes. Okay, so this is going to be 960 out of 2646. So now let's work that out on our calculators and let's see what answer we get. Oopsie, 2646. So I'm getting 0.251198,489 for this one. For this one over here, 2646, I'm getting 0.188,964, blah, 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 blah. Okay, so can you see the left-hand side is not going to equal the right-hand side? Okay, so the probability of someone being from area 1 and earning less than 3,200 Rand a month. No, sorry, less than. Sorry, I was right the first time. And earning less than 3,200 Rand a month is not equal to the probability of someone being from area 1 multiplied the probability of them earning less than 3,200 Rand a month. So therefore, again, we've got to answer the question. The events are not independent. Okay, does that make sense to everybody?